So here we're going to look at an example where we have to calculate, we're given an equation, for a chemical reaction. We have to identify the oxidant and the reductant. Okay, so what we know is that a redox reaction involves a change in oxidation numbers, okay? So what we're going to do to identify what substance is oxidized and what substance is reduced is we're going to calculate the oxidation number of every element in the equation before and after the reaction has taken place. Okay, so when we have silver nitrate here, we know that we can rewrite that, and this is the way we find oxidation numbers. We have to rewrite it as its individual ions. Okay, so we have a silver ion and a nitrate ion, have a lead, we have a lead ion, have a nitrate ion, and we have silver. Okay, so here we know that this is just an ion by itself, okay, and because the net charge is +1, that means the oxidation number has to be +1. Okay, here we know that oxygen is more electronegative than nitrogen, and so therefore the oxidation number of oxygen will be -2, because when oxygen forms an ion, it likes to have a charge of 2-. Okay, and because there's 3 oxygens, that gives a total of -6. Okay, and we need to get to -1, okay, because that's the charge on the nitrate ion. Okay, so we've got 3 oxygen atoms, all with an oxidation number of -2, giving a total of -6. Okay, and we need to get back to -1, which means nitrogen will have an oxidation number of +5. Okay, lead is by itself, it's got no charge, so its oxidation number is going to be 0. Just like we had with silver with +1, lead is by itself, this lead ion, okay, so it's going to have an oxidation number of +2. Okay, the nitrate ion is the same as before. We've still got just a nitrate ion by itself. Oxygen, more electronegative, -2. Nitrogen, we need to make the total oxidation number of the sum of the oxidation numbers in nitrate. We need to make it -1, so therefore nitrogen is going to have an oxidation number of +5. Okay, and then we have the oxidation number of silver. It's a metal, it's by itself, it's going to be 0. Okay, so now let's identify the oxidant and the reductant. Okay, so here we have the oxidant. Okay, we know the oxidant causes oxidation of something else, and therefore it is reduced. Okay, and that's where the confusion comes in. Okay, it is reduced. And we know that reduction means that there is a loss of electrons. Sorry, scrap that. It means there is a decrease in oxidation number. Okay, so we look at the we know that this is the middle of the equation. This is the middle of the chemical equation here. Okay, and we know that here silver has an oxidation number of +1. Here it has an oxidation number of 0. So that's a decrease. Okay, that's a decrease. Okay, and so therefore we know that silver is reduced. Okay, now if this silver ion is reduced, that means we say that the silver ion is the oxidant. Okay, so we say Ag plus is the oxidant. Okay, but it is reduced, its oxidation number is decreased, and therefore it is the oxidant. It's causing the oxidation of something else. Okay, and so now we look at the reductant. Okay, we know that the reductant is oxidized. Okay, and that means an increase in the oxidation number. Okay, and so we look at our equation, we look at the oxidation numbers of everything, we look for something that hasn't had an increase in its oxidation number. Okay, so here's lead, has an oxidation number of 0. Here, lead is now an ion, it has an oxidation number of +2. Okay, so therefore lead, solid lead, not the ion, just lead by itself, is being oxidized. Okay, its oxidation number is increasing as a result of the reaction. Okay, so what we're starting with is lead, not a lead ion, so therefore we say lead is the reductant, okay? Just like up here, we started with a silver ion and we ended up with silver. We therefore said the silver ion was the oxidant. Lead, metal lead, is the reductant. Okay, so we've figured this out by saying, you know, the oxidant is reduced and the reductant is oxidized, okay? But, you know, we can really interpret and analyze these definitions by saying, look, yeah, it is reduced, its oxidation number decreases. For that reason, we call it the oxidant. And so it's the oxidant, it's oxidizing something else. So we could say that silver, the silver ion, is oxidizing the lead. Okay, we can say it that way. Similarly, we know that lead is a reductant. It's undergoing an increase in oxidation number and is therefore being oxidized. But because it's the reductant, it's causing the reduction of something else. It's causing the reduction of the silver ion. So we say that lead is reducing the silver ion.